Welcome back to the channel, everybody. I'm Dino, and today is part 5 of our 5-part series on the Suzuki DR650's electrical system. Specifically, today is all about the lighting system on the motorcycle itself. And it's interesting because only a few days ago, on April 8th, 2024, Niagara Falls experienced one of the more unique things that's going to ever happen in my lifetime, and that is a total solar eclipse. So Niagara Falls was thrust into the darkness for about 8 minutes, and it was so impressive it even got my wife on camera as we watched the lights go down in Niagara Falls. And really it highlighted the importance of your electrical system and the reliability of that electrical system to be able to light the way and have other people see you. So why don't we start with some general overviews of the electrical system and how it works before we get into anything too specific. The DR650 really is a prehistoric motorcycle designed all the way back in the late 80s. This bike was basically introduced in 1996 the way we see it today, with really no changes since that introduction. And it carries over some features from the previous DR650 model. Now, it does have, I guess, a modern charging system in the fact that the lighting system, the charging system, everything is all 12 volts, whereas in past motorcycles in the 70s, some of those even had AC powered headlights and sort of stop lights on the back, especially enduro models that didn't have a battery or electric start, oftentimes would be powered directly off the magneto. And if you blew your headlight, well, the tail light was pretty much going to pop in the not too distant future as that added voltage pressure overloaded the bulb in the tail, leaving you with zero lights and really an unreliable electrical system. However, more modern motorcycles like the DR650 started to introduce AC rectifier regulators into the system, and that's what takes the 3-phase power from your stator and converts it into a consistent regulated DC voltage between around 13.5 and 14.2 volts. And all of the bulbs and systems in the machine are designed to run on that. However, as I said, there are some carryovers from previous models. The turn signal pods and the headlight are all still incandescent bulbs even today in 2024. And the bike is designed to run with those incandescent bulbs. In fact, if you just go and change them out haphazardly, what you're going to find is your turn signals won't work, and sometimes you can even run into problems with the tail light not working right if you choose the wrong type of LED bulb. Here are the 5 styles, basic styles of light bulbs that you're going to find on a DR650. So let's start over here with the smallest light. Now this one is burnt out. This is one of your indicator lights. So when I say indicators, I mean those 3 bulbs up on your dash for neutral, turn, and high beams. These are a push-in style 2-watt incandescent bulb, and as of the making of this video, I haven't found an LED replacement for these, but I'm on the hunt for them. This one here is a 5-watt single filament twist-in style bulb, and this is your license plate light that's located underneath your cover. You take 2 bolts off underneath your fender, the light then lifts off, the cover lifts off, and it exposes your license plate light. I haven't replaced this with an LED, but I'm sure this one's probably easy to find. Next is a single filament. This is an 1156 light, and it is in your turn signal pods. This is what you would find when you buy the bike new. And this would be 21 watts, I believe, is what these are. So when you turn on your turn signal, this bulb is what flashes. Next to that is an 1157. So 1156, 1157. 1157 has dual filaments, and you can tell because there's two contacts on the bottom like that. This one, I believe, is a 21 watt brake light and a 5 watt running light. So when you turn the bike on, that's what you get. Next to that is your high-low beam, your headlight bulb basically. This is an H4 style halogen with 3 plugs on the back like that. So these are the 5 styles of bulbs that you're going to find. The speedometer has a bulb, I believe, similar to this as well. The only difference is I believe it's a little bit lower wattage, I think. It depends on the year. On 96 to 2000, it's a 3 watt. And from 2001 on, it's a 1.7 watt bulb. I don't know why it's that different, but you know, you can always go to your Suzuki dealer and get these. That's where I'm going to go to get this replacement one for my high beam. And if I do find LEDs, you know what, I'll probably change those out so they're a little bit brighter. But there is your standard sort of issuance of light bulbs that you're going to find in your DR650. My bike has been upgraded to have those LED turn signals, stop, tail light, and headlight. And I'm going to talk a little bit about that in today's video as we talk about the type of bulbs that are in the bike, how to convert the bike over. I've got a video out there on how to do that, but we're going to briefly talk about it today as well. But we're also going to talk about sort of how to trace out a problem if you have one, how to check your switches, and you know, things like your turn signal relay, where's it located and how does it work within the system. Maybe the best thing to do now is look a little bit at the schematics for the lighting system so you can get an even better idea how this system works before you get in there. And talking about that, as I always say, if you're going to start working on your motorcycle, and as I found over the last 4 or 5 episodes, getting into the electrical system, you really want to get yourself a manual. Manuals are an important part of servicing and maintaining your motorcycle. They can save you hours of research on the internet, and because those manuals are vetted professionally, you can be confident in the information that's in them. In fact, the Climber's Manual, in my opinion, is probably more accurate than the factory Suzuki manual, which has been picked over by some of the most hardcore DR owners and has been shown to have some errors in it. So get yourself a Climber's Manual, get on some forums, ask some questions, and get wrenching on your DR650. So now, let's take a close look at that schematic because it's just so exciting. So here is the wiring diagram out of the Climber's Manual. And the thing I like about Climber's Manuals, I've said this before, they are well color coded. They match the colored wires within the motorcycle so you can find the different sockets and the different wires within the bike without having to do a lot of work. Climbers has done that for you. And if you're not used to wiring diagrams, this can look really, really intimidating. I know for myself, this is not my strong point, so it takes me a while to walk through it. But the more you work with these, trust me, the easier it gets. There are a couple things on the main wiring diagram I want to look at, and that is down here in the lower right corner is your battery ground and the fact that your starter is grounded. And that is demonstrated with this symbol here. Your main battery ground is a cable that runs from the battery over to the frame. And you're going to want to make sure that this is nice and clean, both at the battery and at the frame end. And also, the starter itself is grounded to the engine. And as you can kind of trace out here, some of the grounds sort of work their way over to the starter and use that to get through to the battery in the end, basically. So because this is really complex, I'm going to slim it down here a little bit and get rid of some of the electrical components that we don't need to worry about with the lighting system. So here's what we end up with. Now this is still somewhat complicated. And you can further subdivide this into basically 3 primary systems is what I want to look at. There is the running light system, the signal light system, and the system that's probably the simplest that I want to look at right now, which is your brake light system. So let's look at this one a little bit closer. Your brake assembly, or your brake light assembly, again, I think is the simplest of the systems, the lighting systems on the DR650. It has some built-in redundancies, which I like. Essentially, though, the light assembly and all of the electrical assembly, really, on the lighting side, is fed by one of 2 ways. It's either powered directly from the battery over here, or power from the stator here, depending on whether the motorcycle is running or it's not, with just the ignition powered on. Power flows up the red wire all the way across to the ignition switch. You can see it coming in over here. In the case of the brake assembly here, the brake light assembly, when you turn the ignition key to the on position, power is allowed to flow through one of 2 pathways to create redundancy. It either flows through this gray wire here, heading over to the front brake switch, or down through this orange cable to the rear brake switch. Now, this orange cable would be shared with other systems, but when you break it out into its own wiring diagram, you can see the pathway quite clearly. Now, when either the front brake lever is pulled in or the brake pedal is stepped on, the switches are activated. So in the case of the front brake, that switch is located underneath the brake lever itself, and it is replaceable, and you can even service it to a certain degree. The rear brake switch is the cylinder mounted switch with a spring on the bottom that's connected to your brake pedal. And it's activated like a plunger. When you step on the brake, it pulls the plunger out, closes the contacts, and allows power to flow. Interestingly, the rear brake switch connector, the part that actually connects into the motorcycle's wiring harness, is not located down near the foot pedal. It's in a bit of an odd place, but it makes sense if you think about it. If you follow the wire, it runs on the front of the swing arm across to the left-hand side of the motorcycle and ends up right here, up near your regulator rectifier up at the top here. But it does make sense. It's really protecting that connector from water crossings or road grime or anything like that it might see down near the brake pedal. So it's up here, and again, if you look at it, it's color coordinated to the wiring harness. So you know this is the connector because it has an orange wire and a black wire with a white stripe. So again, those wiring diagrams are so important for locating things like this. It makes your life way, way easier. But testing it would be the same way. You take it apart, you hook up your alligator clips, and then you cycle the rear brake pedal. If you don't have a buddy like I do when Carl comes over, just hang a weight on it, like a 10-pound weight or a bag of sugar or whatever you have around the house to activate the pedal, and then you can test for continuity. And the fact that the connector for the rear brake light switch is so remote ties in with the idea of redundancy in the system. It's really nice that it's fed by 2 different power sources for both the front brake switch and the rear brake switch. So if you do have some corrosion or maybe a wire wears through, there's a very good chance that if you're using both brakes in tandem, the rear light's going to work if the bulb is still good. Now, the front brake is, like I say, a little easier to show you how to test it. So why don't we take a look at that right now. Most of the switches in the light system are the same way for testing. You're looking for continuity. So when you close that switch, whether it's push a button, step on a pedal, or turn a key, what you want to see is power flowing from one side of the switch to the other. So let's sort of walk through that now. Located underneath your front brake lever here is the front brake switch. And it's really easy to see and it's easy to disconnect for testing purposes. It has two spade connectors that are pushed onto the contacts of the switch. It's easy to separate those either by wiggling them off with your fingers, or you could use a small screwdriver and sort of push them off gently to expose the spade connectors on the switch. The first thing that we want to do is test for continuity. To do this, we're going to use our multimeter. We're going to set it to the continuity function or the ohms function on the machine, and we need to connect to those two spade posts. In this case, I'm going to use a couple jumper cables that in turn I'll connect up to the probes on my multimeter. I'll squeeze the front brake lever and we should see continuity on the meter itself. If you don't see continuity, or the continuity is intermittent, the switch is more than likely bad and it's something that you want to replace. They're around $30 Canadian to replace that. And one thing that I will point out is my switch is giving me a little bit of problems. It has a bit of a dead spot just past the initial engagement of the switch. So I'll pull my brake lever in, the switch will light up, but if I pull it just a couple millimeters further, well, the switch starts to flicker. Then I pull it through that and it lights up perfectly. So I know I've got a problem with that, and I'm going to switch out that switch in a future video and dive a little deeper into how I know it's that switch and not a short somewhere else in the system. If the switch checks out really good, there's no problems with the switch, you may want to dig a bit deeper on a circuit like this to see if the power and the ground wires are working well. So since we have the glad hands off, let's test the positive side of this circuit first, the one that's providing power to the switch. What you'll need is a test light, or you can use your multimeter set to 20 volts DC. Connect your test light or your multimeter to the negative side of the battery or a good solid ground close to the battery. And then with the ignition powered on, you're going to probe the power providing side of the connection. This will light up the test light nice and bright, or you should see a voltage reading on your multimeter close to whatever your battery voltage is at the time when you're doing the testing. If you have a very, very low voltage, or the test light's really dim and your battery is in good condition, there may be some parasitic draw either through a short or a break in the wiring harness that you're gonna have to chase down and see if you can repair it. Normally you can. You can also wiggle the handlebars while you're testing. You'll see if the voltage goes up or the light gets brighter or turns off completely. And that's a good indication that the wiring harness somewhere in there is loose, got a break in it, and as you move the handlebars around, the connection's making contact and disconnecting as you move the handlebars. And you can do this on the wiring harness too by just shaking it around while you're testing any of the circuits on the bike. It's a really good thing to do. To test the output side of that switch, or pretty much any switch, it's all the same, what I'm going to do is I'm going to connect this white jumper here to the output wire, the one that runs from the switch takes the hot power and runs it back to the light itself. Now I'm using this white jumper cable here because my probes on my multimeter aren't really long enough to reach all the way to the back. Some actually are. But you'll see I have it connected to the red side of my probes here. It runs back to the multimeter and ultimately to the black probe on this side. Now, the colors really don't matter. This is just the way I have mine hooked up. But we're going to use this black probe with our multimeter set to the continuity function, and we're going to go down here to the socket itself to test for continuity. Removing this lens cover is really simple. Use a really good quality Phillips, or better yet a JIS screwdriver. Loosen off these two bolts and then the lens cover pulls right out. That will expose your bulb here. Push in, twist counterclockwise, and the bulb comes out. Once you have the bulb out, what you're going to see in the bottom of the socket are two copper contacts. You can see them clearly here. The right side contact is your brake light contact. This is the one that should run directly up to the switch, and the one that we have the white alligator clip connected to. Using the black probe, I am going to touch that and we should hear an audible tone. That's exactly what we want to hear. Touching it anywhere else on the socket or even the other contact should not produce any tone at all. Only this one. Now, if you touch this and you don't get any sound, you don't get any continuity, chances are there's a problem within the wiring harness, or perhaps maybe the socket where it's connected, and you have to dig a little bit deeper and look for a problem. This one's working well, so I can put the bulb back together and we should be good to go. While we're on the topic of looking for bad grounds and bad shorts, let's just take a look at a standard 1157 light bulb socket. This is what you're probably going to find in your tail light assembly. It has two connections here for a bulb like this LED that has two connections. An 1156 bulb is going to have a single connection because it's only got one filament in there. What you'll see is, if we open this up, it's kind of hard to tell, this green wire is soldered right to the outside of the socket itself. That's your negative path to flow to ground. So this somehow will find its way onto the frame and back to the battery. These two connections power the low and high beam side, or the high and low filaments in your bulb. And these are keyed. An 1156 bulb is differentiated in that these two posts are side by side on the bulb. 1157s and I think 3257s, they have staggered pins. They're keyed into the sockets differently so that these contacts here line up properly. And this is a really cheap socket. I think I got 4 of these for $10 on Amazon just to do this video. So what you want to look at is, see, this is the sort of the short side, this is the long side. You're going to want to make sure you line these up right, slide them in so that they line up. To demonstrate how this works, and these are really cheap sockets that I bought on Amazon, the colors aren't going to match what's on your DR here. This is just for an example. I am going to hook my yellow ground wire to the green ground cable. And you can see now when I apply power to the white wire, well, it's pretty bright. But when I apply power to the blue cable, it's even brighter. The white cable in this case would be your running lights, and the blue cable would be your brake lights. Using the wiring diagram, you can trace these out to understand which one is powering your brake and which one is powering your running light. Because according to the diagram, the running light or parking light is fed by a completely independent system from both your brake light system and your headlight system. Even though this comes on when you turn on your headlights, there is further redundancy in that this is fed by its own power source. And that secondary source comes directly out of the ignition. It's the brown wire listed on the wiring diagram. It feeds only one circuit that powers the running lamp inside your tail light and the license plate light. That's all it does. It does have a secondary purpose though. There's a reason it's separated from your headlight, and that is if you were to take your ignition key and keep turning it counterclockwise past your steering lock, there's a section there, a position labeled as P. When you turn the key that far, it turns on your tail light and your license plate light as a parking lamp. So I suppose if you were parking at night or maybe in the fog along a roadway and you wanted to make your bike more visible while you run in to grab yourself a piece of pizza, you could do that at the risk of wearing out your battery. But it is a nice feature to have. Now, if you look at the wiring diagram, up near the front of the motorcycle, that circuit has a blank connector labeled NC, no connection. Now that is keyed power. I'm not sure how many amps it can take, but I used it when I installed my custom dash on this bike to run a relay, just to trigger the relay, which then takes power directly from the battery, feeds a sub panel that I have, a whole bunch of other crap under the dash. But it is a nice little thing to know is there that you can use for keyed power to trigger relays. It's really a good little connection to know about. Before we get into the next system, which is the headlight itself, I just want to briefly talk about my motorcycle. I have a custom dash that I built on my motorcycle, and I also run a Cyclops LED bulb in my headlight fixture. This makes my bike much different than the stock DR650, but there are still a lot of similarities. I used the stock headlight housing and just moved it out from my motorcycle. So there are two JIS Phillips screws that are built into that headlight assembly to adjust that headlight fixture to aim it down the road. Now I'm not going to show you how to do that today because it's not really part of the electrical system. It's more of a system onto itself. But if you want me to do a video on that, I can later. Leave it down in the comments below. The retainer for the headlight is exactly the same. So I'm going to show you that. I'll take my dash apart and show you how that works. And in fact, maybe what I'll do is I'm going to see if I can dig through some old footage and show you how the headlight works on this now. Just like the brake light assembly, we're going to take a look at the wiring diagram here for the running light assembly as well. So here is again the total wiring diagram, but we're going to strip out the running lights here. Now, we've already talked about the license plate light and the rear running light. We're not going to talk about that now. I just want to focus on the headlight assembly. What you're going to see is after power comes into the ignition switch through the red wire and the ignition is turned on, power flows out the gray wire directly across to the speedometer light. So as soon as you turn on your ignition, your speedometer should light up. However, power is tapped from that gray wire and runs up through the same connector that's shared with the front brake switch. It flows across and back down through that same connector, turning into a yellow wire. And that yellow wire runs across over to your headlight dimmer switch. Now, depending on whether you select your high or your low beam, power will flow out either through a yellow wire or a gray wire over to the two 10 amp fuses that are located on the right hand side of the motorcycle underneath the side covers near your right thigh. Now, low beam is the gray wire, or white wire I should say, and it flows directly to the headlight. There's no real changes. It just basically lights that up and then runs back to ground. However, when you select the high beam, the yellow wire is now powering the high beam filament, but power is also tapped off to light up that small 2-watt bulb in your indicators on the dashboard. After that, it finds ground and returns back to the battery. So you get up in the morning, it's a little dark out, but you've got an epic ride planned with your friends. You turn the ignition on and something's not right with old Sparky up here. Maybe the high beam isn't working, or maybe the low beam filament's not working right, but for whatever reason, you've got problems in Headlightville. What are you gonna do? Well, what you'll hear me say all the time is when you're testing electrical circuits, you want to start out at the load, the furthest part away, and work your way back to the battery. But with the headlight bulb, it's a little bit time consuming to pull it out and have a look at it. So there's a couple things I think I would do first. Number one is I'm going to go down to where those fuses are on the right hand side, and I'm going to check the corresponding fuse. I'm going to pull it out and see if it's still good. I'm going to test it with my multimeter, and if it's blowing, I'm going to put a new fuse in and see if my headlight lights up. If it does, that's great. I can head out for my ride, but I want to keep something in my head. Something caused that fuse to blow. Could have been anything. Maybe I was monkeying around there and touched something with a screwdriver and shorted that fuse out. Maybe there was some kind of power surge. Maybe my regulator rectifier starting to break down a little bit and flashed that fuse and it popped. Or maybe because the DR650's headlight turns with the front forks, maybe the feed to that is starting to bend, chafe through, and maybe it has made contact with the frame and shorted that out. If you find the fuse continually blows, that's probably a good thing to think about, and you may want to take the system apart, trace that wire out, and look for any kind of damage, especially around the pivot points up here around the forks. Now, if you check the fuse out and the fuse is good, well, then you're going to break out your test light and you're going to test first down at the fuse on the positive side of the fuse holder. Turn the ignition on, probe around there, make sure you are getting power to the fuse holder down at the bike. If you're not, you're going to follow back up to the handlebars, test all the connection points, test to make sure the switch is putting power out to the other side and that it's getting power from the ignition. You work your way all the way back up to the ignition switch, testing to make sure the ignition switch is getting power and that power is coming out through that white or gray wire that's coming out from the underside. You continue to do this all the way back to the battery. And again, I can't stress enough, make sure all your main grounds are nice and clean. These are the types of things with all the systems on the motorcycle that you're gonna get into practice doing and learning. And believe me, we're into our 5th episode here. The electrical system actually starts to make sense to you. It is for me. I feel much more confident working on this bike and any bike that I happen to come across when it comes to electronics and electrical systems. I am nowhere near an expert, believe me, I'm not, but I'm much more confident now that I've been working on the DR. So let's say that you've traced it all back and you believe it is the headlight bulb. How do we get the headlight bulb out so that you can change it? Well, I'm going to use again some stock footage here and I'm going to walk you through how to do that. To remove the headlight bulb assembly from the headlight fixture, we start by removing our upper fairing here. And that's held in place by 3 small screws, 2 on the side and 1 underneath the headlight itself. Once you get those out, the fairing lifts off and reveals the headlight fixture itself. The headlight fixture is held in place with 4 bolts, 2 on either side, that you need to remove to tilt the headlight assembly forward. Once you do that, you can then grab and remove the plug that's connected to the back of the bulb here. With that gone, there is a small metal clip that runs around the back of the light bulb that you simply squeeze, if I remember right, and take off, and then the bulb pulls out. Now there is also a rubber grommet that fits in there that you have to deal with, but it's pretty self-explanatory once you see it. Now, reinstallation is exactly the same. Just keep in mind the bulbs have these 3 keys on them and they go in a certain way. This is so that the filaments line up correctly and your beam projection is nice and accurate when you put it back together. Apply a little bit of dielectric grease onto the connectors, put the main connector back on, and reassembly is the opposite or the reverse of how you got it out. Put everything back together and you should be ready to roll. Now that we've wrapped up the running light system, I want to talk about the third and final system in the lighting system of the motorcycle, and that is the turn signals. Now, in my opinion, the turn signal system is the hardest system to understand within the overall lighting package. It's not that it has a lot of complex components. It only has some light bulbs, a signal switch, and a flasher relay, but it's the way in which those all work together to make the system function properly. I will point out at this time that my bike has been upgraded with LEDs, and I've done a couple things within the system to change it and allow it to work properly with LED bulbs. But for this video, we are going to talk about the stock incandescent bulbs and how those function within the bike to make the system work. If you want to know how to convert your bike over to LED bulbs, I'll include a link down below to tell you how to do that. So where do we start? Where I want to start is right here with what Suzuki calls a dashboard. It's really only 3 light bulbs, and I specifically want to talk about the center one, the turn signal lamp on the dashboard. Now, unlike modern motorcycles that have an indicator light for left and right, the DR650 is somewhat prehistoric in the fact that it has a single light bulb that flashes in unison with either the left or right turn signal circuit. It doesn't distinguish between the two, and that single light bulb does make the system a little bit more difficult for most people to understand. I know I was really kind of confused when I first looked at the wiring diagram, and I think that's maybe the place to start first, is to look at the wiring diagram and walk through the path of power to understand how this thing works. Well, once again, here is the full DR650 wiring diagram, and I'll pare this down to the turn circuits. Here you can see those, and I think for this example I'm even going to remove a few more things here, and the things like the stator and the feed up to the ignition, just because they just complicate things. And that leaves us with what you're seeing here. I think it's important to note that DC power really flows from the negative side of the battery all the way around and back into the positive side. That's how the electrons flow, negative to positive. But the way I'm going to explain this today, I'm going to do it in reverse, from positive to negative, only because it seems to make more sense to me to explain how this works. So let's first take a look at just generally how a turn signal circuit would work. So as it sits like this, everything's neutral until such time as you activate the turn signal switch. Let's just say you want to make a right-hand turn, so you hit the switch. Power is going to flow from the ignition down to the turn signal relay, over to the turn signal switch, and then out the green wire to both the front and the rear bulbs on the right hand side. Both of these bulbs have a circuit, so the power flows through them, and then they head out through that black and white grounding line all the way back to the negative side of the battery. That forms a basic circuit. The flasher, which is a thermal flasher, heats up and cools off and heats up and cools off. opening and closing the circuit and making the lights flash. And this is how your basic light system works, your turn signals work. If you were to call for left-hand signals, it would flow out the black wire through the bulb to the black and white ground wires. The flasher relay would open and close as it heats up and cools off, and your left-hand turn signals would work. This is the most rudimentary way to make this thing function. The challenge is when you introduce the indicator bulb, the turn signal bulb, up here in the left-hand corner. If you look at this, the bulb is fed by two different potential power sources depending on whether it's a right or a left-hand turn. But there is no direct pathway to ground. If you look at it, they're tied in only to the positive sides of the circuit. I believe this is called a bridging circuit. It bridges the positive power coming in and out. What happens here is, let's say you're calling for a right-hand turn. Power flows up that green wire, goes through the right-hand turn bulbs, both of them, but it also can select to go up and through the indicator light up in the top left. Now it passes through here and then passes over through the black wire, which is the positive feed for the left-hand turn signal bulbs. From there, it passes through the filament to the ground on the left-hand turn signals and finds its way back to the battery. Now, the way this works is the turn signal itself, that indicator bulb is only 2 watts, and the bigger turn signal bulbs are like 21 watts. So the lower wattage bulb lights up, and it doesn't provide enough amperage, I believe, is what happens to actually light the larger bulbs in the returning circuit. So what you end up with is the indicator bulb flashes with the right-hand turn signals, and there's just not enough remaining voltage pressure to light up or electrify the left-hand turn signal bulbs. It's so bizarre how this works, but somehow it does. And I can show you that this is the way here in a live demonstration. I want to try to represent this so you can see how this works. And again, I'm not 100% sure, but this is my speculation on how this works. If we look at this 21 watt turn signal right here, this bulb here, I can take it and light it up. It's connected through the green wire to ground. And if I touch it, you'll see it lights up nice and bright. This circuit works fine. I'll use my test light to represent the low wattage bulb in your dashboard, in the indicator light. And what I'll do is I'll take the ground clamp of that test light and I'll connect it to the positive side of the 21 watt bulb. What you would think would happen is, because these are in series, that they would both light up, and this one would be dim and this one would be dim. But watch what happens. When I touch this to the positive side, only the low wattage bulb lights up, and it uses the filament for the high wattage bulb as the ground circuit to get back there. So this is how your turn signals work to light up that dashboard light, but it's also why when you put LEDs in the system that they actually light up. And let me demonstrate that now. Now here is the exact same setup as we had before, other than the fact I've replaced that incandescent bulb with this LED bulb here. It's wired up exactly the same way. So what do you think happens when we touch our probe now to the positive side? Let's have a look and see. Okay, that's interesting. This lights up very dim, but the LED is nice and bright. The reason for that is the LED is really a lower wattage bulb than what's in the test light. The test light's still incandescent. So the amp draw here is much higher than the amp draw there. It lets power pass through and it lights up the bulb that we traditionally would have used as the grounding circuit in the DR650. This is exactly why when you just replace your turn signal bulbs with LEDs, that all four light up, because all four of those probably draw less amps than the 2-watt bulb that is in the dashboard. So this is sort of how that system works. It's really bizarre. It's old technology, but this is why if you want to upgrade to LEDs, you need to do a little bit more work, and I'll include the link to that video in the description. Okay, I promise I'm done with the wiring diagrams for this video. And with that, why don't we look at how to change the light bulb on the little mini dash here if you ever do burn a light bulb out. It's relatively easy. It's the same for all 3 bulbs that are under there. I'm going to show you how to do that right now. Using a 4mm Allen key, I'm going to remove this small machine screw that holds the dash in place. Now use your finger and hold the screw on the Allen key and it comes out easy. Next, I'm going to pry this off using a flat-bladed screwdriver. It's soft rubber and it will just slide off of the ignition key cylinder really easy. You can even reposition it a little bit if you want to get better access. Under the rubber grommet, you'll see there are 3 separate light fixtures basically just pushed up into the housings. This one on the right is your neutral light. The center is your turn signal. And this one out here on the left is your high beam light. And my high beam light's burnt out, so we're going to change it. So I'm just going to grab the wires and gently wiggle them until the fixture pulls out like that. And you can tell that this bulb is burnt out simply because it looks silvery in color. You can't even see the filament anymore, so I'm confident that this one is burnt out. Now, if it was in good shape, I wouldn't touch this with my fingers, but because it's burnt out, I'm just going to grab the light and I'm going to pull it straight out of the fixture like that, and I'll buy a new bulb and replace it. Now, with the light bulb back in the housing, you can simply slide the grommet over top of the key tumblers here, tighten down that machine screw with your 4mm Allen key. You don't have to over tighten it, just snug. And you're done. The dash is back in. And that leads us to the last thing in this video that I want to talk about, which is your turn signal pods down here. So why don't we talk about that a little bit? The factory Suzuki DR650 turn signal pods really are not known for their aesthetic good looks. Quite frankly, they're pretty ugly and it's a throwback into the 80s. But they are functional, and because they're rubber mounted, if you do happen to drop the motorcycle, there's a good chance they're going to survive. To change a light bulb in one of these, it's a pretty straightforward process. There are 3 self-tapping screws that come in from the back side of the turn signal pod and anchor into the amber lens at the front. Now, these use a Phillips or a JIS style screw head in them, but I find that they're pretty cheap fasteners, and even a good quality JIS screwdriver has a hard time getting a bite on these things. To make it worse, they are recessed into a cylinder pocket that makes some screwdrivers almost impossible to reach the fastener. The screwdriver that I found works the best is one of these small number 2 Milwaukee drill drivers that I have an adapter handle for. So it'll take a drill driver handle, or a drill driver bit, sorry. It snaps into the handle and makes a screwdriver. Milwaukee bits seem to work really well in JIS screws, and these pods here are no different. You can back these out, get the lens cover off, and then you simply twist the bulb out like any automotive bulb and out it comes and you can change it. When it comes to reinstalling your amber lens cover, there's a few things I want you to remember. The first is there are 2 different size screws, or 2 different lengths of screws, I should say. There's 2 long ones and 1 short one. The short one goes to the outside of the pod and the two long ones go to the inside. The other thing I want you to remember is you need to make sure that lens cap is lined up in the black pod itself. You can sort of get it in there cockeyed, and when you go to tighten things up, it can damage the amber lens. And that brings me to my last point. Don't over tighten these things. If you put too much torque on those screws, you're going to pull the threads right out of the amber lens cap, which is going to mean you're either going to have to somehow repair it with epoxy or glue or something, or you're going to end up buying a new lens cap at Suzuki, and no one wants to do that. I mean, who wants to spend extra money for ugly pods? Other than that, it's a pretty simple install. Anybody can do it. You just need to take your time. Speaking of time, I think I have spent as much time as I want to talking about the DR650's electrical system. In total, I think all 5 episodes add up to over 3.5 hours of DR650 electrical system. It's like way more than I ever thought it would be. It's like a Lord of the Rings episode or something. And I hope that somebody out there appreciates it. It was a huge learning experience for me. And I highly encourage you to sort of tackle some of this. It really boosts your confidence to go through each system and understand how it works. I actually, in the end, had fun. I might not admit it to everybody, but I will to you. But that does bring the series to a close. Now, it's springtime here. It's only 6 degrees outside and it's almost the end of April. So we had a warm February and April's chilly. But I do want to get my motorcycle back together and get out and do some riding. It's been in pieces all winter as I work through this electrical series and other different videos. So I do want to get onto some videos that maybe don't necessarily entail tearing the bike apart. One of those, of course, will be the dashboard. I am going to start assembling this dashboard and gluing it together. But unfortunately, in order to test it, I have to take my bike apart again to bolt this up. So I'll probably reassemble this. I'll do a video on how I got to this point maybe. I have a couple other videos like how to change the switch on the front brake for the tail light. I'll do that, a couple smaller ones. And I'm hoping to get a couple ride videos out too. I know they're not as popular as some of the technical stuff, but I want to do some riding too. That's why I originally bought the motorcycle. So until then, I really do hope that you enjoy coming by the Tinker Shed here. I know I just loved seeing all the comments and seeing the subscriptions grow. And if you do like the channel, again, leave a comment, like, subscribe, do all that great stuff that makes the channel grow. And until then, I'm Dino. You have a great day and tinker easy. I'll see you soon.